Imagine one office switch with finance, engineering, and guest Wi-Fi all plugged into it. Same box, same cables, yet finance cannot see engineering, and guests cannot see anyone. One physical switch, behaving like three separate networks. That trick is called a VLAN, and it runs on a few lines of configuration. Let's decode it. I'm Tessa, and this is Envision Decoded. VLAN stands for Virtual Local Area Network. It lets you slice one physical switch into multiple logical networks. Each port on the switch gets assigned to a VLAN, say VLAN 10 for finance, VLAN 20 for engineering, VLAN 30 for guests. Devices in the same VLAN talk to each other normally. Devices in different VLANs cannot talk at all unless a router deliberately connects them. Why slice a network up? 3 reasons you have heard before, because they rhyme with why we subnet. Security. Guests and finance should not share a neighborhood. Performance. Broadcast chatter stays inside its own VLAN instead of flooding everyone. And organization. Teams, floors, or device types each get their own tidy segment, without buying a separate switch for each. VLANs are subnetting's physical world partner. Let's build it. Picture a 12-port switch. In the config, you assign ports 1 to 4 to VLAN 10, finance, ports 5 to 8 to VLAN 20, engineering, ports 9 to 12 to VLAN 30, guests. That assignment is the whole foundation. The switch now treats each group as its own isolated network. Now watch a frame try to cross. A finance PC on port 2 sends to another finance PC on port 4. Same VLAN, delivered, exactly like a normal switch. The same PC tries to reach an engineering server on port 6, different VLAN, and the switch simply will not forward it. Not blocked by a rule, just no path. It is as if the 2 ports live in different buildings. But what about the cable between 2 switches or up to the router? That link has to carry every VLAN at once, and it is called a trunk. To keep the traffic sorted, each frame on a trunk gets a small tag with its VLAN number, that is, the 802.1Q tag. The receiving switch reads the tag, sees VLAN 20, and delivers the frame only to VLAN 20 ports. Tag on the trunk, untagged at the desk. And when finance genuinely needs to reach an engineering server, traffic between VLANs must go through a router or a layer 3 switch, where you can apply rules about exactly what is allowed. VLANs separate by default, routing reconnects by exception, ideally through a firewall policy like episode 14. So, to decode it. A VLAN slices one physical switch into several logical networks. Ports are assigned to VLANs, same VLAN talks, different VLANs cannot. Trunk links carry all VLANs between switches, using 802.1Q tags to keep frames sorted. And VLAN-to-VLAN traffic must pass through a router, which is where your rules live. Separate by default, connect by exception. If VLANs finally clicked, hit subscribe so the next one finds you, and a like really helps. Next time, a small mystery we skipped. Your device knows an IP address, but cables deliver to MAC addresses. How does it find the MAC behind an IP? That is ARP. I'm Tessa, this was Envision Decoded. See you in the next one.